Today we are graphing linear inequalities. So that means we're going to see less thans and greater than signs today. And when you graph with less thans and greater thans, there's shading involved. Okay, so one thing I do want to make sure that we do is we want to make sure that the equation is solved for y. So y equals or y greater than or equal, or y is less than or equal. If it's solved for y, it's ready to go. If it's not solved for y and you end up dividing or multiplying by a negative number, remember that you have to flip your inequality sign. So when solving for y, if you divide or multiply by a negative number, you'll have to flip around your inequality sign. Okay, and then also you will need to remember that if there is an equal sign under the symbol, then that's a solid line. But if there is not an equal symbol, then it's a dashed line. So if you see equal symbols, make it a solid line. And if there's no equal symbols, it's a dashed line. And then if it says y is greater or y is greater than or equal to, we shade above the graph. But if it says y is less or y is less than or equal, we shade below the graph. All right, let's just try it. All right, so number one, it is solve for y. Y is by itself. And remember, if you see x and y, it makes a diagonal line. X and y makes a diagonal line. So every time it's a diagonal line, remember to plot the y-intercept first. The y-intercept's the b, the number behind the x. So do you remember who it is behind the x when you don't see it? It's a 0. So we plot a y-intercept of 0 right there. Then you take care of slope. And slope is the number smushed with the x. Well, who's smushed against the x that you don't see? A 1. So if your slope is 1, it's up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. Or you can reverse and go down 1, left 1, down 1, left 1, down 1, left 1. Okay, solid or dashed? We see an equals, so remember if there's an equal symbol, it's solid. So we're going to make a solid line, which means that every point on this line is an answer to this equation here. And then shade above or shade below? Greater, y is greater, we shade above. So I'm going to shade everything above this line. What this means is that every point in this shaded section is an answer to this problem. And because it's a solid line, every point on the line is also an answer to this problem. Okay, so if you know how to graph a line, so far, this shouldn't be too bad. All right, number 2. Y is solved for, it's by itself. Is this going to be a diagonal line? Yep. Remember, x and y makes a diagonal line. So every time it's a diagonal line, remember that you plot the b, the y-intercept first. So which of these is the y-intercept? The y-intercept is that positive 4 there. So y-intercepts always go on the y-axis. So let's go up to 4 and plot 4 on the y-axis. Now we want to take care of slope. And slope is the number smushed with the x. So our slope is that negative 1/2. What do you think that's telling us to do? It's telling us to go down 1, right 2. Down 1, right 2. If I want to reverse, I can go up 1 and left 2. Okay, solid or dashed? There's no equal symbol under this, so if there's no equal symbol, it's a dashed line. Okay, what that means is that no point on this line is an answer to the problem. Shade above or shade below? it says y is less than, we shade below. So I'm going to shade everything below this line. So every point in this shaded section is an answer to this problem, but no point on the line is an answer. Do you remember doing this ever in your past? Okay, let's keep trying. All right, looking at number 3. Just going to blow this up a little bit so you can see better. That's not going to do it. There we go. All right, is number 3 going to be diagonal? Yes, x and y makes a diagonal line. All right, so every time it's diagonal, a diagonal line, you plot the y-intercept first. So who's the b in this problem? Since you don't see a number behind the x, then b is understood to be 0. So our y-intercept is 0. So we're going to plot 0 on the y-axis. And then who do you think slope is? Slope's the number smushed with the x, so our slope is -4. And what do you think a slope of -4 tells you to do? Down 4 and right 1. Remember, every number is understood to be over a positive 1, so down 4, right 1. Or you can reverse it and go up 4 and left 1. Okay, solid or dashed? If you have to look up in the box up there, you can always do that. And equals is a solid line. So every point on the line is an answer. Shade above or shade below? Below. Less than, we shade below. I think it's kind of fun. All right, let's go to 5. Now, is this one solved for y? Nope. All right, so remember, we want y all by itself. I know it's going to be diagonal because there's an x and a y. So let's make it look like this, and then we'll do it just like 1, 2, and 3. All right, so if y is what I want by itself, remember how I used to circle y just to remind myself that that's what I'm trying to get by itself? Okay, so if something is outside the circle, then we have to add or subtract it to make it go away because we're trying to zero it out. So since this is a positive 2x, we're going to have to subtract it. So we're going to subtract 2x from both sides. That way, 2x minus 2x is 0. Shoop. The negative y comes down. Your symbol comes down. Remember, you can't add and subtract things unless they're like terms, and this has an x and that doesn't. So I want the x after the equals. So I'm going to bring this negative 2x down first, and then I'm going to bring down the negative 2 after that. Now, I can't stop until it's a positive y. So remember, this is a negative 1 in front of that you don't see. So to undo multiplication, I divide. So I'm going to divide both sides by -1. So that way, -1 divided by -1 makes a positive 1. And if it's a positive 1, you don't have to write it. Uh-oh, I'm dividing by a negative. Remember, if you divide or multiply an inequality by a negative number, you flip your inequality sign. So I need to flip this inequality sign around. So flip it. And now let's reduce the other side. So remember, this is divided by -1 and this is divided by -1. So let's do this first. What's -2 divided by -1? A positive 2. Don't forget the x. What's -2 divided by -1? A positive 2. Okay, so now it's ready to graph. Y is all by itself, just like on 1, 2, and 3. I know it's diagonal because x and y makes a diagonal line. So let's plot the y-intercept first. Remember, the y-intercept's the b, the number behind the x. So my y-intercept is positive 2. Y-intercepts always go on the y-axis. So plot 2 on the y-axis. And then slope's the number in front of the x. And my slope is that 2 right there that's smushed with the x. So I go up 2, right 1, up 2, right 1, up 2, right 1. Remember, every number is understood to be over a positive 1. Or reverse it, you can go down 2 and left 1, down 2 and left 1. Now, this is the equation we want to be looking at for which way we're going to shade. First of all, solid or dashed? Solid, there's an equals, so it's a solid line. And it's here where y is by itself that we look to see. Shade above or shade below? Greater than, we shade above. So shade everything above your line. Chugga, 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 chugga. Kind of fun, don't you think? Okay, what do you think about number 6? What do you think we're going to have to do? We're going to need to solve for y. X and y makes a diagonal line. So I know it's going to be diagonal, so I want y by itself. All right, let me circle that y to remind myself to get it by itself. Remember, if something's outside the circle, we have to add or subtract to make it 0 away. So what do you think you'll do? Subtract 3x. Since it's a positive 3x, you have to do the opposite to make it 0. That way 3 minus 3 is 0, so 3x minus 3x is 0. Shoop. You're going to bring down your minus 5y that's in your circle. You're going to bring down your symbol. Remember, you can't add or subtract unless they're like terms, and this has an x and that doesn't. So I'm going to bring the x down first. So this is a minus 3x. So bring the minus 3x down first, and then bring down the number, and that's a positive 10. Okay, and then to get y by itself, to undo this multiplication here, I divide. So I'm dividing both sides by negative 5. So negative 5 divided by negative 5 makes a positive 1. So if it's a positive 1, you don't have to write it. Anything you want to tell me? Flip that sign. If you divide by a negative number or multiply by a negative number, you flip that inequality sign around. So I'm going to flip it around. Choop. And now let's reduce the other side. So what is a negative divided by a negative? A positive. So it's a positive 3/5 x. And if I could reduce 3/5, I would, but I can't. And then what's a positive 10 divided by negative 5? A negative 2. All right, we're ready to graph. We already know it's diagonal because x and y makes a diagonal line. So who's the y-intercept? Who's the b? This negative 2. So y-intercepts go on the y-axis, so I go down to negative 2. And who's my slope? 3/5. Slope is the m, the number smushed with the x. So if a slope is 3/5, what do? We go up 3 and right 5. So up 3 and right 5. 1, 2, 3, 4, 5. What if you need a reverse? Down 3 and left 5. And then solid or dashed line. There's no equal, so it's dashed. So that means that no point on this line is an answer to the problem. And then you want to look where you got y by itself. Do you think you'll shade above or shade below? Above. Greater than, we shade above. So I shade everything above. And all those rules are up in that box up above. So just to review for a second. If it says y greater, we shade above. But if it says y is less, we shade below. If there's equal symbols, it's a solid line. And if there's no equal symbols, then it's a dashed. Okay. Let's look at number 7 here. Anything you notice? It's not diagonal. It doesn't have an x and a y. X and y makes a diagonal line. This is not diagonal. All these others on the front page, they were all diagonal, as you can see. And that's because all the equations had x's and y's. So if it doesn't have an x and a y, it's either hoy or vux. Do you know who this is? If it's an x, it's vux. So V stands for vertical. So I'm going to make a vertical line. So I go to where x is 4. Remember, this is your x-axis. So I go right, 1, 2, 3, 4. And I'm going to make a vertical line. But is it solid or is it dashed? It's dashed. There's no equals. So it's a dashed line. Now, this is the only time I don't think above and below, because there's not really an above and below. There's a right side and left side. So I actually read this and do what it says. This says x is greater than 4. So where are numbers greater than 4? To the right or to the left? To the right. So I shade everything to the right. And that's my answer. Okay, anything you notice about number 8? It's not diagonal either. Remember, x and y makes a diagonal line. So is this hoy or vux? This is hoy. If it's a y, it's hoy. And h stands for horizontal. So first we go to where the y is a -3. Now the y-axis is up and down, so I need to go down. And that's where my y is a -3. And then I need to make myself a horizontal line. Will it be solid or dashed? Dashed, because there's no equal sign. Now I can go back to shade above, shade below. So less than, we shade below. Okay, so all of those were all linear. They were diagonal lines, horizontal lines, or vertical lines. But what do you notice about these guys? See the absolute value bars? If you see absolute value, they are going to be V-shaped graphs. So down here, they're all going to be V-shaped, either opening up or opening down. So anytime you see the absolute value bars, they're going to be V-shaped. Okay, now we can do the translation rules. The left, right, up, down, if the M is a 1. So is my M a 1 in this problem? Yep, there's a 1 smushed up against that X. You just don't see it. Yay! So I get to do the whole left, right, up, down. Do you remember what the -4 inside is going to make the graph do? Go right. How about the +5 in the back? Go up. All right, so instead of starting at 0, 0, I am going to go right 4 and up 5. 1, 2, 3, 4. And then I need to know my slope. And slope is anything smushed with the x. So who's our slope? 1. You don't see a number there. So the slope's 1. So from the vertex, up 1, right 1, up 1, right 1, up 1, right 1. But remember, I need the other half to the V. So go back to the vertex and go up 1, left 1, up 1, left 1, up 1, left 1. Okay, solid or dashed? Solid. It's got an equals, so it's a solid V. And do I shade above or below? Less than, I shade below. So I'm going to shade everything below my V. And there's my graph. Okay, let's look at number 2. It's my washing machine again. Oh my gosh, that thing's going to break down any day. All right, do you notice anything about number 2? It's not solved for y. Y is not by itself. See? All right, so to get rid of subtraction of 1, I'm going to add 1. Now this zeroes out, the y drops down, the symbol drops down, the negative drops down, the absolute value, the 4x drops down. Now here's something you need to know. I cannot add the 8 and the 1 because the 8 is inside the absolute value bars, but the 1 is not. So it's going to say stay +8 inside, and this +1 is just going to go in the back. All right, this time, is our M a 1? Nope. M is that 4 right there. So that means we have to use this formula. Opposite of B over M, comma C. Remember that? So you get to do the whole left, right, up, down translation rules if your m's a 1. If your m is not, we have to use this formula. Okay, so m is the 4, b is the 8, and c is the 1 in the back. Remember, m and b are always inside the absolute value bars. M is smushed with the x, and b is behind the x. And c is what's ever added or subtracted outside. This little negative is going to have to do with slope. Okay, so let's follow the formula. It says opposite of b. So what's the opposite of a positive 8? A negative 8. Divide by m, and m is this 4 right here, comma, c is this positive 1. Now let's reduce. What's negative 8 divided by 4? Negative 2. So our vertex is negative 2, comma 1. Okay, so remember, x is left and right, y is up and down when you plot points. So from 0, 0, I go left 2 and up 1. Now I need to deal with slope. What do you think the slope of this is? The slope is negative 4. The slope is anything smushed with the x, inside, outside, or a combination of both. So slope is negative 4. And remember, every number is understood to be over a positive 1. So how do we do a slope of negative 4? We go down 4 and right 1. Down 4 and right 1. And then to get the other half of the v, go back to your vertex. Down 4, left 1. Down 4, left 1. All right, now let's look at this equation. Solid or dashed? Because there's an equals, it's going to be solid. So make yourself a solid V. And do we shade above or do we shade below? Greater than, we shade above. So I'm going to shade everything above my V. This is below it. This is above it. And there it is. It looks like a peacock. Okay, let's go to number 3. First of all, is our M a 1? Yep, M is inside the absolute value bars, smushed with the X, and you don't see anything, so M's a 1. Yay! That means we get to do translation rules. And Y is by itself, so we're ready to go. So what's the plus 2 inside going to make you do? Left 2. And how about the minus 3 in the back? Down 3. Okay, so I'm going to start at 0, 0, and I'm going to go left 2, choo, choo, and down 3. Doo, doo, doo. Now I need to know something about the slope. Who do you think the slope is? A negative 1. Slope is anything smushed with the X. And remember, every number is understood to be over a positive 1. So we're going to go down 1, right 1, down 1, right 1, down 1, right 1. To get the other half, go back to your vertex, down 1, left 1, down 1, left 1, down 1, left 1. All right, solid or dashed? There's no equals, so it's dashed. So no point on this V is an answer. Whereas if it's solid, every point on the V is an answer, just like with the lines. Shade above or shade below? Greater than, we shade above. So everything above the V, another peacock. Okay, so now we're going to look at pictures and write the equations. Here we had equations and made pictures, so we're flip-flopping. Okay, so remember, if it's a diagonal line, there's a what in the equation? X and Y makes a diagonal line. So every time it's diagonal, we know there's going to be an X and a Y, so this is the equation we're going to use. We have two things to figure out, slope and the y-intercept. Okay, so let's do that. First, let's figure out the y-intercept. The y-intercept is where the graph is touching the y-axis, and that's that guy right there. That's where the graph is touching the y-axis. What's that number? -1. So -1 is our y-intercept. Okay, now I need to do slope. And remember, you find slope by counting rise over run or fall over run. So to get from the left point to the right point, I rise up 1, 2, 3, 4. So my rise is a 4. And my run is a 1, 2. Remember, you always reduce fractions if you can. And 4 divided by 2 is 2. So this one has a slope of 2. Now, if there was no shading, this would be an equal sign. But because there's shading, we need to worry about less than, equal, greater, greater than, or equal. So is this shading above or below the line? The shading is above the line. So anytime the shading's above, we use a greater than symbol. Will it get an equals? Nope, because it's dashed. And that's our equation. Not so bad. All right, let's look at number 2. It's diagonal, so we're going to do the same thing. All right, we need to figure out the slope and we need to figure out the y-intercept. So I'm going to go ahead and get my y and x in there. Let's figure out the y-intercept first. Where does the graph touch the y-axis? At -2. Okay, so we put -2 behind the x because that's the y-intercept. Now let's figure out our slope by counting rise over run. So I'm going to go from left point to right point. I rise 1, 2, and I run 6. Well, can we reduce that? We sure can. We can divide both of those numbers by 2. 2 divided by 2 is 1, and 6 divided by 2 is 3. So our slope is 1/3. So we put that smushed with the x. Now, is our shading above or below the line? The shading's below the line. So anytime the shading is below the line, we use a less than. Now, will it get an equals? Yep, it's a solid line, so it gets an equals. And that's our equation, and we're done. Okay, we've got some more to do. So we're looking at pictures and writing equations. Now, is this guy diagonal? Nope. So he's either hoi or vux. Who do you think he is? It's horizontal, so it is going to be hoi. H stands for horizontal. O stands for 0 slope. Y stands for it's a y equation. All right, so what's your y value everywhere right here? Your y value is a -1. Okay, now let's see if we can figure out the symbol. The numbers that are shaded, are they y's that are greater than -1, or are they y's that are less than -1? These are y's that are greater than -1. Does it get an equals? Nope, because it's dashed. Also remember, when the shading is above, above is a greater than sign. Okay, looking at number 4. Is this diagonal? Nope. So is it hoi or vux? This is vux. Remember, V stands for vertical line. This is vertical. U stands for undefined, and that means it's an x equation. Okay, what is our x value everywhere right here? Our x is a 6. Okay, now let's figure out the sign. This time we don't have above and below. So the numbers that are shaded, are these x values that are bigger than 6 or x values that are smaller than 6? They're x values that are smaller than 6. And because it's a solid line, we give it an equals. All right, now what do you think is going to be in the equations of these pictures? Absolute value bars. Remember, your V-shaped graphs are absolute value. Now, these are kind of hard to tell again because the graphs aren't maybe big enough for you to see, or you can't see the grids well enough, but they either go up 1, right 1, or they go down 1, right 1. So the slope is either 1 or -1. It's not always that way, but it is in these problems. All right, so with these problems, if the slope is a 1 or a -1, then I just need to know how it moves. So how did the vertex get here from 0, 0? It went right 3 and up 2. Right 3 and up 2. Okay, so to make something go left or right, remember that goes inside. So to make it go right 3, do you remember what it is? -3. And to make it go up 2, +2. Very good. Now let's figure out our symbol. Is the shading above or below the V? The shading is above the V. So above is greater than. Does it get an equals? Yep, it's a solid V, so it's an equals. All right, let's just hop down to number 7. How did our vertex get here from 0, 0? It went right 4 and up 5. Right 4 and up 5. And hopefully you can see that for yourselves. Okay, so what do you think you'll put inside? X minus 4. That's going to make it go right 4. What do you think you're going to put in the back? +5. That's going to make it go up 5. Okay? Now, is the shading above or below? The shading is below. So when it's below, it is a less than. Will it get an equals? Nope. But there is something we have to do. Do you know what it is? Since the graph opens down, the slope is negative, so we need to put a little negative out in the front there. You need to do another one of these? I'm just going to do it. One more. All right, so I'm hopping to 6. How did our vertex get to where it is from 0, 0? It went left 4 and down 3. So left 4 and down 3. All right, so who do you think is going to be on the inside? X plus 4. Plus inside makes it go left. Who do you think is going to be on the outside? -3. Very good. Okay, is the shading above or below the V? The shading is below the V. So if the shading's below, we use a less than. Will it get an equals? You betcha. It's a solid line, so it gets an equals. And since the slope is positive, since it opens up, we don't need to worry about a little negative there. And that's this lesson. Smiley face.